So we can start now. Let me start sharing my screen. So here, share. So 1 second. So what is about the class today? I see already a question on here, Zoom, that what should we talk about today? And the question is that I see that to share, I have to first authorize this, and I need to join again. So we have here a little bit of a technical interruption. Let me authorize this, and I join again. Yeah, so in 1 second. So it's authorized. Let's see, share screen. Now I hope that you can see our chat. And here is the screen, so I will maximize it. Perfect. So it seems I do not need to leave Zoom, but now I'm recording and sharing. Please interrupt me if there is something that you want to have clarified or that is not clear. Also, I would like to warn you that often I tend to speak fast. So if you feel that the speed of my voice is too fast or not clear, just feel free to interrupt me and I can repeat it again. On the chat question was antipatterns. And yes, so this is what we'll talk about today. So what's the plan for today? I will spend now some minutes on giving an overview of the class. I will introduce an overview antipatterns. We'll go through the most common antipatterns in Python as well as in machine learning. Of course, antipatterns is often a matter of opinion. It can be that there are antipatterns that you're familiar, that we're not discussing. Here I selected those that I have faced throughout the experience that I have had doing both programs in Python as well as developing machine learning models. After that, well, we'll have a quiz. And this is a little bit different to the mechanics that we had until now, where first we had a class and at the end, in the evening, we had a quiz. Here, the idea is that in the end, we have covered quite some ground in tools and topics. And so in order to become good in software engineering, we need to be hands-on. It's not just sufficient to say, I will have the theory, but I will not apply it. So we have prepared a very nice task for this, where you will be able to develop and deploy all the things that you have learned over these past 2 weeks. So from Bash to Docker, patterns, antipatterns, and so on. You will have enough time for this. And after that, you will submit the solutions. I will explain how to do it. And once the quiz is over, we will still have some time to go through a couple of them and discuss them. And so to see what the person did and so on. Because as we have been seeing in the quizzes, one of the things with design patterns and in general software engineering is that it is very opinionated. You can see it from the chats that people say, oh, but I expected this and I'm not getting that and so on. Well, because reality is that it depends a lot on our own experience with programming, what we believe is a good pattern, what we believe is good software engineering. So it makes us a lot of sense not only to develop ourselves, but also to look into the solutions of others to get these best practices and different type of coding styles. But let's get started with antipatterns. So what is antipatterns? The last class, so with Alexei, we discussed about patterns, design patterns for all or object-oriented languages, but primarily about Python patterns. And we saw that they help a lot in order to make our code, well, more legible, to make so to have cookie color solutions that help us organize things better, and also to maintain it better, because we saw the biggest problem that often we have the situation where we work on a project for some weeks or some months, then we change to something new, and when we go back to our old project, then we don't really know what happened. So our project didn't have a structure, it was a bit chaotic, and as a result, we are lost and we waste time, or we have to start from scratch. So the idea is that we use patterns to bring some structure into it. Antipattern is basically the opposite. Antipattern is something that we often see in programming, so in code bases, we often see in GitHub repositories, and people use it, even though this is not necessarily a good thing. It can be a bad thing for multiple reasons. One could be, for example, that this is not corresponding to the language. For example, a programmer can be programming for years using Java, and suddenly the person decides to start doing Python. And although both Java and Python, they are object-oriented programming languages, and also they are modern languages, and as well as they share similar design patterns, they are not the same. There are things that make Python unique, and when someone with Java experience start working with Python, it might do things that are not necessarily appropriate for the language itself. So this will be an anti-pattern. Anti-pattern could be also things that somehow work, but also they are not really efficient. They can consume a lot of memory, they can be slow, they can just be ugly. The idea is that we'll look at 20 of them, we will see why they're bad, and we'll see what could be the better option. Hopefully, among those anti-patterns that you have seen, there are some that you have been doing and that you realize that you can do better. So let's see the first one. And actually, this first one, we have seen it already in previous classes. So when opening files, or in general resources, we were discussing about opening files in previous classes, and we saw that there was this with statement, and it was maybe not that clear because it's not that common to see with statements. But we see it constantly when we work with resources, opening a text file, opening a JSON file, and so on. However, this is not the only way, and often it's not even the most common way how people open a file. I can do, if you can see my screen, I can here at the bottom, you say here anti-pattern, and what can I do? I can just use the open, so call some file, and so to say that I will read it. I can use this file, and then at the end I have to close it. This is also a way to work with it. The problem is that very frequently we forget about closing the resource. So this is inefficient because we're consuming memory, we can be leaking it, and it's not a good idea. Fortunately, Python has a very nice construct, which is so the context manager. With is a context manager. And what does that mean? It means that as long as we are within the with statement, the resource will be available. But once we leave the with statement, this resource will automatically be closed. So if we see the best practice, we see that we just have to use with. We still call the open some file, so here. And the syntax, it looks very similar to when we do so we iterate through a list. So we call here the open file. We can just read it, and that's it. So next I can just continue, and I don't need to close it. So this is really, given that we are, as data scientists, as machine learning so experts, that we are often working with files, this will be definitely the one that I see it a lot, and yet people don't do it properly in that they don't use a context manager. Context manager itself is a great also construct that you can use not only for opening files, but in general managing any type of resources. For example, a very nice implementation of this, you can see it in PyTorch. In PyTorch, you have seen that when you're working with it, you have to call the context manager, so the with statement. And what happens basically is that way, PyTorch can manage the GPUs and then close it when it's not needed. Yeah, so let's go to the second one. So here it is about using a list, dictionary, and set comprehension so necessarily. So one of the nice things about Python is that you have these constructs in order to create lists, dictionaries, and sets on the fly. So I do not need to write a for element in a list, and then iterate it as it is in other programming languages. But I can just do it in a list, in an anonymous list directly. So we can see here at the bottom. I mean by this. Right? So it scroll down. I didn't want that, but I mean this. So where I created a list by just declaring it with the square brackets, and then inside the list I am basically so populating it with the values from these my favorite superheroes. And the idea is that I just want to so create a string that will become a separated. So I could just do it like this. However, this is not even necessary. Why is that? Because very often I can work directly with the generator expression. In this case, what does that mean? Well, it means that here I do not need to create the list just by using, given that, so in join with strings, I can use a generator. I can just declare it as well as that. So I would say that why we should go one over the other. Well, in the end, lists are objects that are occupying memory. So here we have, if we are working with very large lists, if we have many of them and so on, it can become already a problem. Second, well, in the case of join and generator expressions, they are optimized for this. So we are here wasting so some time. And then, so for example, so we can use also so functions such as all and any and so on. So I see here a chat. Let me see what it said. So the question is, so is this iterator or generator inside? So the generator will be here at the bottom. The comprehension will be on top. An iterator or an iter is basically just a general construct. So as a way to create a new collection. So let's say that you have a class and you want to be able to so organize this class sorted and so on. You will create an iterator for that. So it would be a bit different. And here I have, so you will see that Ivan very kindly provided an example. So yeah, so basically that. So this is also, again, something that we work a lot as data scientists. So all the time we're going through lists. Often we have to manipulate these collections. And so when I mean lists, I don't mean only lists, but also dictionaries and sets. So in general, collections. So we have to work a lot with collections. And we need to do operations on them. And for example, as in this case, use it as strings. And we see that often we do it suboptimal. Let's see here, a couple more questions. Okay, here, even again, a conduit clarification. True, I agree. So let's go to the next one. I would say if you have questions, so for each of them, one option is either, okay, you can continue writing, but otherwise, once we come towards the end, we'll have some time dedicated, allotted to having any questions. Because as I said in the beginning, antipatterns and also design patterns are opinionated. So you will say, oh, but I use it and it works perfectly fine. And I saw somewhere in Stack Overflow that people use it and they say it's fine. That's correct. But still, you'll also find a large part or a large group of the Python community, or the machine learning community, who will tell you, no, this is ugly, this is wrong for this and these reasons. So the nice thing about this is that one can debate very enthusiastically on the topic. Another question we have, arguments to join, we pass neither generator or list. Well, we're passing the collection, and so the generator is in join itself. So so join acts as a generator here. Let's go to, so basically exactly that. So when we are initially using generators, so over here the antipattern. Well, what we discuss is that, so here the generators is, we can declare it, for example, as in the case on top, where we have these square brackets explicitly, but I can also as well, as a generator, have it as it would be an object. So for example, I could do something such as, so we can write down in the bottom, I could say here list, and here in list, I can have exactly this here. So this will also be a generator for a list, and it will work as well between the brackets and also the declaration of the object list, as it is here. And you will say, well, so is there a difference? Well, in fact, yes. So it's not exactly Pythonic to do it this way. So we see here in the example, the squares. What we're doing is we want to declare a dictionary. So we're basically, so we're iterating to a range. We are calling, we're doing an operation on each element of the range. And then, so the first element will be our key. So each element, and the value will be the operation that is done on the element. So in theory, we'll say this works perfectly fine, but it's not Pythonic, because the Pythonic way to do it, it is to use the square brackets. And if I will be having here a list, well, so the example will be, let's say, so here, this list, and I will just do here the operation and these elements. Yes, so this will be the equivalent. And if I want to do it the proper way, well, I'll do with the square brackets as I was describing. So here is something where I would say the reason to use it is more to make the code more Pythonic, more cleaner. And so from a performance perspective, I do not think that there are any differences in performance itself, but it looks nicer to be using it the way that Python is meant to use. The fourth one. So returning more than one object type in function call. And what does it mean by this? Well, and actually it's also something that so we often see in our code. So for example, we have some kind of so logic control sequence. For example, if, then that. Let me see here, and some more questions in the chat that have accumulated. And what about append? Well, append is to add a new element in a list. So you have to want a new element, so I will use append. So if you mean on, I see that Ivan is here very kindly answering, so I will leave that to him. So let's continue with that. So in our fourth, anti-pattern. So returning more than one object type in function call. So what is this meant by that? Well, very often we'll have a situation where, for example, so in this case, I want to so have the person age, and then I think very nicely, okay, I want to make sure that the object that I am getting is actually a person, because as we have seen with Python, it is not strictly typed, and then we do not, when we're passing objects, we don't really know what they are. We have to be aware when we create them. You can tell me, yes, but now we have so these type declarations, and I can just say, so let's say here, a name, and it will be type person and so on. Yeah, so it could be an option. Yes, but at the same time, this doesn't work fully in practice, and often my experience is that it doesn't catch many times. So this syntax is very nice for documentation purposes, but if we're talking about letting letting Python detect it, very often it will not necessarily work. So we cannot really trust it, and as such, this in this case will not help. Yet we do it very frequently. This where we're saying it's okay, we want to get from our database some person, the name, and then if this is a person, then I want to return the age. But what happens if this is not a person? Well, we will get a none. And we know that nonce in Python is a little bit problematic. So you know it, for example, when working with scikit-learn. One of the most common reasons why scikit-learn models fail is because at some point we're passing a nonce as a result and so on. And we might not detect this if we are working in large code bases, if we have a very large data set and so on. And this is here a problem, yeah? So in this very trivial example, we see that this is one of the very common things that happen in machine learning. And or also another alternative that we see often is if, so cases, so for example, so if, so let's say, if let's say not a person, return, yeah, so that we have all these cases for returning. And this is not a nice this is not a nice thing, because that means that then when we call the function, we have then to catch all this again. So we have code duplication here, and also in the part where we're having our so calling this function get person age, we again need to catch if I'm returning person age, if I'm getting person age, do this, if I'm not getting it, do that, and so on. So not only we have here the risk that things go wrong downstream, but also that we are writing too much code when it's unnecessarily. So what can we do in these cases? Because this is quite common to happen. Well, we have to raise exceptions. So what does that mean? Let's see here, I see something new in the chat. Let's see if, okay, I see Sivan's answer. So it doesn't matter. So let's continue.
Sorry, Rodrigo, I will moderate the chat, so you don't worry about this.
Okay? All right, thank you very much. Thank you, amazing. Yeah, thanks. Very kind. So the idea here is that we only have one return type. So here we can see the difference. In the first example, after each if, we're returning something. And here we're saying if the condition is not met, if not person, then this will raise an exception. And this is very nice because we can catch exceptions. This is also a very object-oriented good practice. In the course, we have not covered it so far because in the end, it's a small course and there are so many nice things to cover. But definitely looking into exceptions and working with exceptions is a very professional way to do things, and what I encourage you to get into. Also because in this case, we'll not see it, but for example, a longer example could be, and I see it also often in scripts, in homework and so on, when we have, for example, a lot of ifs, if person, if animal, if dog, and so on. So we have 10 different cases where you're checking and then doing something. And this not necessarily because the nice thing about exceptions is that we can create logic for this. We can declare, we can either use existing exception types, or we can declare our own and then handle the logic. We can just say, if exception, we can ignore it, we can stop the program, or we can have some kind of logic behind. And this is much more nicer. Also, for example, when we're doing logging, we can do our logs in that they only report the exceptions that are raised. So that way we do not have a huge file, full of all type of print statements and comments and so on that are not critical, that are not key, but rather we only have the exceptions that are like important and that can be a problem for our program. So here in the end, what we did is we're still calling to get our person, but we're checking that if it is not the person, and if it's not the person, we'll raise the exception. Otherwise, it will continue and it will return the person age. And that way, we can say that this method will always return person age. So much nicer, much more Pythonic, and cleaner as well. Another one that is also very common with dictionaries, and so why is that? So the antipattern is not using get to return default values from a dictionary. And so the situation here is that often people see dictionaries as just lists with the values, or basically lists. What do I mean by that? Well, we can see here that we declare a currency map where we want to say, for example, if you have a USD, then it means US dollar. And we can have, let's say, so if you have here a euro, it will be euro and so on. Yeah? So this is, let's say, something very common that happened where we have abbreviations and so on, or country names. If it is RU, it's Russia, etc. Very, very common situation. And then at some point, we have to have some logic for saying, well, if I found, let's say, RU, I want to give back that it will be Russian rubles. And then I will write again, very similar as what we had above. I will write one case for this and so on. And we might have a question that what happens if we have here, so here as I declared euro, or here as I declared US dollar. Well, in our if, so logic control, it will go to the else and it will return undefined. This is this is not nice because the consumer of our library, so it can be us or it can be another programmer, they might not know that the person defined undefined. And what happens if I instead say, so I return, scrolls, return def. Again, I will not know what it is. So I will have a situation where I am having to make the consumer of this, so if this is a function, if this is a method, to catch all these or to consider all these corner cases. This is not nice, and it can lead to consequences later. It can be that we forget about it, and then later we do not know what to do it. Also because in the end, for Python itself, passing on def is nothing wrong. So it's just another type of another value. So there is no way for us programmatically to detect it unless somewhere else we have if on def in x, and then we do something. So unless we know specifically that we have on def in previously as a potential value for our currency map logic, we will not be able to catch it, and Python will not be able to detect it either. Yet there is something very nice in dictionaries for Python, which is get. And allow is very nice. I do not see it as often as I would like. So get, what it does is it does exactly this logic for everyone. So, and here I can just put here instead of on defend, I can put just none. Yeah, so none. So the nice thing about this is that it will say, okay, I will look for the key, in this case, I and R, and if it is in my dictionary, so here I and R, so if it is, I will return Indian rupees. But if it's, let's say here I want euro now. But if it's not, I will return none. So this is much more nicer, much more Pythonic, and it is a consistent way how to handle the not finding a key in a dictionary. This is also something that can happen much more often than you might think, because dictionaries and lists and basically any with exception of sets. So dictionaries and lists are mutable structures in Python. What do I mean by that? I mean that a change done at some point in our program to dictionary will change the whole the original the original definition of the dictionary. More concrete example, what does it mean? I mean that, for example, if I do something like my currency map equals currency map, many people, and also in other languages, one will expect that this generates a new copy of currency map, and now we have two copies in memory, my currency map and currency map. So if I go and then I just say my currency map, and let's say that I want just to let's update. So I want to add a new element. I want to add Mexican peso, say something. Mexican peso. So I have added in my currency map a new element called my Mexican peso, and then I will be thinking, okay, I have now two dictionaries. I have the first one that has only two elements, dollars, and the other one has Indian rupees. And I created a second dictionary that is called my currency map, where I have a third one. So we have dollars, rupees, and pesos. But that's not the case, because my currency map is only pointing to the object currency map. So the object has two declarations, my currency map and currency map. So any change that I do here will impact what is happening here. That's why it's important that I work with this get construct, because that way, if for some reason I were to delete and I will not have, I can still handle it. Yeah. So let's go to the next one. Items to iterate over dictionary. This happened a lot in Python 2.7. I think in Python 3 it is no longer the case. One needs to use obligatory items, but still. And this comes down to what I was mentioning before, that so many people see lists and dictionaries as basically the same in how to employ it. And in other programming languages, that's as well the case. So one will not use a different syntax for example, iterating a dictionary or for iterating a list. So one will use, for example, this, that I want to iterate over my dictionary to do something, to retrieve the values. So I will just declare my for loop, and this country map will be a dictionary, or let's say currency map, to have it more consistent with what we have above. Currency map. And then in the loop, I will use the key to get the value. So in various programming languages, they will be perfectly fine. And in Python will work, but this is definitely not Pythonic, and is not the how people do it. So the most common way how people do it, and how it should be done actually, is that one iterates through the items. So here what we are doing is we are we're unpacking the dictionary, and we will obtain the key and the value. The common convention is to put here key, and then he say val. And then I can here say, for example, name is equal to val. So we see that it is cleaner and it is much more concise and Pythonic. So always when we're iterating over a dictionary, we have to use items, and we should not use, we should not call the value on the loop. So when we're iterating over the loop. Yes. So the next one, not using literal syntax to initialize empty list, dict, and set. This is also very common, and I must say I have used it a lot in the past. And why is that? Well, normally, often we have the case of, for example, we have to add items to our loop. So for example, let's say that here, so if we stay in our example here above, that we want to have a list for specific currencies. So that, let's say that I want to have only, here I will update it. Let's say that I want to have only a list for a US dollar and a Mexican peso. So for that, what I will do is I will need to declare first my list of currencies. So let's say that I do something like, I can in theory say here list. Yes. And then here, what I will do is I will say if all the val. If so here so Mexican peso in val, I can have list currency and val. So this is a very common logic where, for example, we want to have some kind of a way to remove elements, or we only want to have certain values and so on. So we have a temporary list that we declare above, and then in our loop, based on certain logic, we'll decide if we append new elements to this list or not. And I can just do this as well with just list. But this is not the Pythonic way, the right way to do it. So here we can see, for example, that I have list with the parentheses. The ideal way will be to use the square brackets. So I will initialize it here, no list, with square brackets. So why is this? Well, this name Dict is in the end we're calling for a specific class. So we will instantiate a class of type Dict, of type list, and this needs to be looked globally by Python. However, using the square brackets, Python knows immediately this will be an empty list. So whenever we want to initialize a list, we just do it with the brackets. This is also the case, for example, when we create an object and we know that one of the properties of the object will be a list. Well, we need to initialize it somehow, and we should be using square brackets. And of course, if we have a dictionary, so it will be with the curly braces. My dictionary, say something, we can have here, like this. Yes. The 8th one, pushing the border in production code. We're talking about software engineering. We are talking about, so here, situations that we have to refactor our code and so on. And here is basically something rather obvious, that it is that we have things that we are using only for our so exploration, and that we do not need at all so for the production code. This can be such as logging, this can be just a certain function that we're calling in order to run tests and so on, and that are not necessary anymore when we're deploying. So here, I see I don't have a specific example, but basically that. So I think that this 8.1 could be rather summarizing, don't have any code in production that you do not really need. So the 9th one, key in list to check if it is contained in list. And for example, we can see this so expression is very common when we're working with strings. So we have, for example, a long sentence. So Rodrigo is explaining foundations of data science. And then this will be my string. And if I want to get, so if I want to know if the word Rodrigo is in it, I will say Rodrigo in string. If Rodrigo in string, then do X. So for example, here we can see it for a list. So similar as for string, that I want to find out if the number 3 is in the list, and then apply some logic. And if it is not, then apply some other logic. And you will say, well, it works perfectly fine. Why not? Well, the problem here is that this is, of course, not very efficient, because when we're using in, then we have to, so Python must be checking for each element if it is or not. And of course, here we have only 4 elements, so this will take, so basically nothing in time. But if you will have a very long list, a very long array and so on, this will be very slow. And what is actually worse is that this is not even actually Pythonic how we can do it, because the Pythonic way is as that we can have just a set. Why is a set and a list? A lot of people often do not know, and they only work with lists. Well, sets basically they are immutable. They're immutable data structures. Just some minutes ago, I was mentioning immutable structure. I was saying that I can remove objects, I can point again, and so on. But sets, once I have created them, I cannot modify them anymore. And also the other thing is that in sets, I cannot have repeated elements. So for example, here in my list, I can have, so the number 4 as many times as I want, and they will all be stored. I can just ask for I can just get the 4 that is in this position as well as the 4 that is in this position. In a set, that does not happen. So in a set, I will only have 1, 2, 3, 4. So a very nice way to do this is just to work with sets by casting the list into a set, and then I can use it in, I can use the same construct. That way, I will remove all duplicate elements, and it will be more efficient. I will also say that another way to do this is I will check, I can check also by position. I can also say, if I know that the number 3 is in the position 2, I can just use also here 2. So that's in the case that I know it. And this is especially the case when I'm working with ordered lists and so on. So, so here the main takeaway is, if you're dealing with large lists who might have duplicate elements, and also if I do not want that this is modified, then I will use a set instead of a list. Another common one, and that we were discussing, so last, I think it was last class, so when we were working with packages and so on, very, very popular, so that I will use so from some library, some package, and then I will import all. And so very common, I say from utils import, so asterisk import all. And this is very comfortable for us to work with, and we see it all the time in homeworks, in projects that we look at GitHub and so on. But this is not nice at all, and for multiple reasons. So first, because when we're working with this statement and we're importing everything, then this needs to be loaded in memory. So we will be loading all the methods that are declared under this package, they will be loaded. And this occupies memory. We do not want this. This is the first reason. Second reason is, of course, because it obscures the logic. So we do not know what actually we're importing. This is I see it with, for example, let's say that you want to work with methods that have a same name. So I want to have my own addition, or I want to also have elements that, so the square root, for example. I want to find a different way to do square root. If I'm importing all from math, then also the square root will be imported, and it will confuse Python if I'm using the same name to define my method for the square root. So not only we are using more memory than we should be doing by importing elements, but also we are obfuscating the logic, and as well as for anyone reading the code, they might not know, so where is it coming? So they might say, okay, where is this method coming from? Where did I call it? Especially when we have multiple from all import. Often you can have 3, 4, 5 that are exactly the same, and we're importing all the functions from the library. So ideally, the best way is to be very specific in importing. Remember that one of the tenets of Python, one of the zen of Python is explicit is better than implicit. So that means that if I only will be using the method, the functions, so here's ceiling, then I will be calling it explicitly. I will not use the asterisk, the star. I will be using it explicitly. And if you want to be even more specific, then nothing stops you from saying, so from calling it directly, so from having import, and then I will have math, and I'll do something here. So this is also very nice because, okay, it's more verbose, okay, it will make the code maybe a little bit more cluttered, but then we are knowing exactly what was called from where and when it was called. Yeah, so always we have to be very specific which functions we're importing from where. So here, but yeah, so people probably would say that there are cases where indeed it makes sense to import the whole model. And when does it make sense? Well, as I mentioned, so especially if we are working with a lot of methods from a given library, it's not comfortable to be every time calling from, from a library, import this method and so on. So if we know for sure that we'll be using most of them, okay, go ahead and use the import all, the asterisk. Then the direct import does not bind to the same name as that for another object. So here's the example for it. I think you import time out error. Yes, and then also we have the situation where we can have valuable information. So especially in notebooks. In notebooks, you see a lot that people call the import just immediately after they will use it. So I will have, for example, if this is cell of a notebook, I have here, so I have this here, then above I am having other logic, yes, and below I am having other logic. So a lot of people, they find it very, very comfortable, and they find it much more cleaner in notebooks to just be calling the library and methods that they need exactly instead of what they'll be using, instead of how it will be in a script where we're having at the top of the file all the imports. And this is true that it's cleaner, especially when we're working with multiple libraries. I can often see 10, 20 imports at once at the top, and it's a bit lost in if you have a script that is 1,000 lines long or longer, then we don't really know where it's coming from. So it is a true cleaner. But still, what can we be using? Well, as I was saying, we can import it directly. So here we have math.sil, or the most popular one with so for example pandas that we see all the time. Import pandas as PD, and then here we have pd.readcsv. So either we try to import it with a shorter name, and also by not a shorter name, but actually we're giving it we're labeling. So here the library, or we are doing it so explicitly. Yeah? So here these two options are much more cleaner than using the import all. So very rarely you will need to use the asterisk and import everything. There are much cleaner and nicer options in Python. The global statement. So this is also something that is not really Pythonic, but one sees a lot when one is working with large classes, large files, and so on. So what is it? Well, we know that so in Python, the variables have scope. What does that mean? It means that this, so here we have a method called area. In this case, a function, so a function called area that has, it accepts basically two parameters, W and H. This W and H only exist within the function. I cannot call them outside of this. So if I put here, let's say like a W, and so let's like print W, I will get an error from Python when I try to run it. They will say it's not defined. And often we might be in the idea that we say, okay, I am using some values to initialize my script, and it makes sense because I have so many settings. How can I make them available across all my functions? And one might be tempted to say, well, I just use the this keyword global. That way, Python knows that this width refers to the width that was declared on the global scope, and not some width that might be local. And this will work. Often, also, one can see it even outside of, even without global. So often one can see, especially in notebooks, I see it very frequently, that people, they just do the following: this. They just say, okay, I declared before in my cell the width and so on, and I'm using it inside the function, but it was never passed as a parameter. So this has multiple problems. Why is that? One is that we do not really know if this was so initialized, so this is for global scope, but also this can be confusing for Python itself if we have local variables that have the same name. And for anyone consuming this, it will be my library that I want other people to use for, and I say, okay, I have the area method, and then there's also width and height. People, by looking at the signature of the function, they will not know that also width and height are used, are modified, are passed as well. So here, very problematic for multiple reasons. One is, as I said, is not a nice practice to have variables that are not passed through the signature of the function. Second, it can be confusing because often we can have a local one and a global one. Something very common is, for example, people do, let's say here, I can have width, I can have here height, yes? I can do here width. So, often out of comfort, we call the names of the variables for the function in the same way as it will be the variables that will be initialized. And in this case, it will be unclear to what is it referring. Is it the local, the global, and so on? But even by using the keyword global is also not nice. So we'll have a lot of bugs. It is ugly and it is not maintainable code. So what are the solutions for this? What can we do? Because we have it all the time. So, well, we create a class for this. So what we'll be doing is, so if we know that we are using this a lot, then why not? We create a class, in this case, the rectangle, and then here we can have these class variables that are, in this case, self to width. Self tells to Python that this width is the class one, and this width here is the local one within the function. So this is a parameter. This is much more cleaner, much more succinct, and if we are using these values frequently, then it makes sense. Later on, we'll see another anti-pattern that is very closely connected to how to handle this, because very few people actually, from what I see in data science and machine learning, will think, okay, if I have some values that I will use a lot, why not I create a class that I will instantiate with these values? They will instead think, oh, I can put all this in a list or in a dictionary and so on. And we'll see an anti-pattern that is in that direction, basically. But here the takeaway is, 1, never use or avoid using global. 2, do not work with variables that are not defined within the function. If you are doing something in the function, always be very explicit in the signature. So here, if I want to work with width, height, W, and H, I will use them here. That way, my IDE, my pie chart, knows the exact signature and can give me an error if, when I am calling, so here area, if I will do something like this, area, this immediately, PyCharm will tell me you're missing 2 arguments. And I could do an introspection and see that indeed I'm missing W and H. So always the elements that we'll be using in the function, in the method, have to be declared in the signature. We don't use global, and we do not use things that do not belong there. And also, if we are using it frequently, then let's create it as a class. That way we can have properties, class properties, that can be referenced throughout the class and outside. This has also another advantage, is that, for example, that way I can create exceptions that, for example, if this is not class rectangle, then throw some mistake and so on. If I'm working with a circle and I have a class rectangle, then it can throw some mistake, etc. So working with classes opens a door to many good things in Python that we will not be able to get access without. Of course, one has to be careful. I mean, the solution is not also to make everything a class, also because this doesn't fit very well with machine learning patterns and data science, given that in libraries such as pandas and so on, we work very functionally. So the solution is not go and create a class for everything, but just think more about what you want to achieve and see if it might make sense to have a class, so to instantiate some values that you will be using throughout so your code. So the next one, 12. So we have 20, so 8 more to go. Assigning a lambda expression to a variable. So this is also common, especially because lambdas are a very nice thing, and when people discover them, they get a little bit excited about them and start using them everywhere. So we see, for example, so one way to define a function is the classical way. I give it a name, so a signature, and then I do something with it. Yeah? So this is the classic one that we all know about in Python. But one other option is that we can have this. We can say it will be called f, and it will be a lambda. What is a lambda? A lambda is an anonymous function. So this is basically a function where the first value is what will be the signature, so this here x, and after the 2 dots, it will be the logic that we will be passing. And you could say that basically list comprehension and so on, there are also lambdas. So there are anonymous functions that have some logic behind. So I can be saying, oh, it looks much more elegant if I do f equals lambda. And in some languages, I have seen that it's also a very common way to do things, but not in Python. In Python, it looks, it doesn't make sense because a lambda is an anonymous function. So why, if it's an anonymous function, you give it a name? It is not something that is the case. So here we can see the explanation. So in the first one, we are specifically saying this is f. And in the second one, this is just an anonymous function, it's generic. It doesn't make sense to give generic an f. So the best practice is definitely, if you know that you will be using this logic often in your code, then give it a name and call it properly. And also you can do it, you don't need to do indented. You don't need to do this. Yeah, so if you think it's only one line, then do it one line. And it still looks very elegant. But don't use lambdas by giving it its own name, its own signature. So that's not a good idea. We will also see later when we can use lambdas, when it makes sense to use lambdas, because actually lambdas is one of the nicer things that in programming languages, in that we can declare functions very quickly for things that we'll be using once or maybe a couple of times. So we'll see some cases where it makes sense to work with lambdas. So now let's look at more. These were basically general Python patterns or anti-patterns per se. But let's look at some that are more specifically to machine learning or data science. Not machine learning, but let's say data science anti-patterns. And for this, I was looking a little bit online, and I was thinking, so what people consider as a machine learning anti-pattern. I was thinking, what do I consider as a machine learning anti-pattern? So let's see, and potentially you might disagree, and we can have an argument about it. Because in the end, this is not the Bible, so this is not something that is official, and if you're doing it, then so this is completely wrong. But this is definitely something that is suboptimal, and whenever you are doing an interview, for example, the interviewer will want to see that you work Pythonically, that you are familiar with the best practice in the language. So if they see that you are doing anti-patterns whenever you are doing a task for the interview, then the person might think, oh, this candidate does not know Python that well, or this candidate does not write good code. And one of the classic cliches of data scientists is that data scientists are not software engineers, that they just do some code that somehow works, but cannot be used by anyone else. And if you are using anti-patterns, then you're basically hinting that. So that's why we need to avoid them. But how do machine learning patterns look like? Well, one example. Make a monolithic config object that you keep passing through all your functions. Very common one that I have seen. And it is very connected to what I was mentioning before. So what happens when I have some values that I will be using throughout my code, and I need to be able to access them somehow. And we saw that one very dirty way was to say, I call the global a keyword, and that way I can get them back. Another way is, why not I pack them at the beginning of my code into a dictionary, so like I have here, let's say my config, and I'll have one parameter, let's say number of epochs, and the one will be max number of epochs, and so on. And then, in this case, I want to do the number of jobs for so scikit, how many jobs I will be working with. And then I can say, okay, I have I have here my function that is train, and I will have my train and data set, my model that I will be passing, and the config dictionary. And very nicely, I can use the get, so the get property from the dictionary in order to retrieve the parameters. And I'm saying if I have a parameter 1, then I want the value. If not, I want -1. That in scikit will mean that you use all, so it can use all cores. And then I want also, after this, I want just to reset the parameter. I will put it to 0. And later, for test, I will work again with the config dictionary and do something. So and then I work with I instantiate all this, I call it, and then I do something. So far, this will work fine. So far, there is here nothing to complain about. And it can be somehow practical, but this is not a good idea for multiple reasons. The first one is, as we're seeing here, we're working with a global object that we're modifying it. And we discussed previously that it's very easy to modify a dictionary without us, or at least without us knowing about it. And this can lead to unintended consequences. So what happens if here I want 0, but later actually wanted to continuously value 2? Well, now it has been modified and I will not have access to it anymore. This is the first reason. The second reason is, well, this looks as a very innocent example, but if we look today at for example, I was looking at the examples from PyTorch, how to use the library. And I saw the config files that people put for examples, and we'll see one in a few more minutes. And this is basically 50 different configuration that we're having there, configuration parameters. So imagine you have a dictionary with 50 different keys and values. At some point, you will no longer know what is inside. And a risk is that you are duplicating, that you can have, so here, that here param1 and param2, they do the same thing, but in different places. So it started becoming very, very, very messy. Also, as we know, the IDE cannot check what's going on. So we cannot basically use the help from the IDE to detect if there is the wrong value. We can also not, so you can also not work with it nicely and so on. So there are a lot of disadvantages of using this approach that is very common, and I acknowledge that I have used it in the past, and I have been taught better by now. So I try to avoid it. So the first thing that we have to use is, okay, if we decide to work with the dictionary, then do pass the exact so the exact value that where we work with. In this case, when we are calling the function, then we'll want parameter 1. So then our function only works with the specific integer, which in this case is 2 or -1 in case it's not included, and then do something. The second thing that here will be done is basically not modify the config dictionary inside the function, because we don't want unintended consequences. But a much more elegant solution, it is what we saw above, which is, let's have a class config, where there I can declare all the main properties that will be for my configuration. I instantiate it, and then I can use it. That way I can work much more nicer with Python, I can work much nicer with IDE, and in addition to this, it will look much more clean in my code. So here we see basically 3 options. Option 1 is, or 2 options. Option 1 is only work with the values, only pass values and not the full dictionary. Option 2, a much more elegant, create a class for this. Connected to this, and it's a little bit connected to the class that we have with Alexei on design patterns. And so we'll see what I mean by that. So let's imagine that we have this situation. Yeah? So we want to work with the command line, with the terminal, and one common thing will be that we want to get the value from the command line. And given that the command line I can write whatever I want, so we need some logic in order to detect that we are passing too many parameters, or that it's not the form and so on. So the most simple way to work with the command line is if I call the system library, and then it has this very nice function called rv. And here I can basically, based on the length of rv, I can just declare some logic, and if it's not logic, then I will just stop my script with exit. So this is something that would work, and that if I have the right length, then I will basically print it, and if not, then I'm not. And also, if I don't have it, then I can just specify that it will not exist, right? So this makes sense, but it's not that nice. An improvement, so we can see here how it happened. So let's say that we call, this is my script, and we call it without any type of arguments. Well, we'll have printed the message that we need to specify path. But if we put more than one argument, then it will tell us we have too many arguments. But if we put one argument, it will tell us what it is. So makes sense, reasonable, but there's something nicer called argparse. So it's another library. The nice thing about argparse is the following. So here what we're having is that we are declaring our argument parser, and we can add to the argument parser different arguments. This is very elegant for the following reasons. One is that here I can give it a name. Yeah, so often you see in a script that we have to put the specific name. For example, path equals something in the command line. Also, I can specify which type it is. In this case, I'm saying it's string. And if the user does not know what to use, for example, we're looking with Alexei when we're looking into, or in general, when we're working with Docker and when we're working with our libraries, we saw that it's possible to see a hint, and this is where we can declare it. So for anyone consuming our script, using argparse instead of just here argv, offer us much more power in that we'll not be required to write some logic to detect if this is a string, an integer, or something else. We can provide hints for the final user, and we can also give them names. So I can here declare many. Then what I do is I just have to parse them once, so to collect all of them once people have typed it on the command line. And then after that, well, I can just print it. But here again, we're seeing something that is a problem. We keep passing the full object. And we're seeing that passing a full object, especially when they're collections, is not really a good idea. So here what we do instead is, well, we know that we want to get path. So we can just create a variable, we can just call it, and basically work with it. So that way also, if we don't have path, we can write some logic to catch it. As an exception, an if, whatever you want. But we are seeing how we went from something that does a job, such as using here the command line to pass arguments in a simple way, to something much more elegant. And you will see that basically everyone who does a script in machine learning, they use rparse. There are similar libraries. rparse is not the only one. There are actually quite many, but rparse is a popular one. So don't use, or rather, use rparse, first point. Second point, whenever you're working with the arguments, pass it to the specific method or function for the property that we want to use, and not the full object, not the full dictionary. Then connected to this, and funnily, exactly this antipattern is found in the examples for PyTorch. And we'll see now why it's not nice. And this is to have a function called getArgs to handle console arguments. So this is basically taken from that PyTorch example, where, well, we can see what I was mentioning before on bad idea with dictionaries, and have it on my configuration file in a dictionary, because in this case, we see how many arguments we have defined, and it will not be clean, it will not be visible, and so on. Another idea could be that, so here, I declare a getArgs method. Here, I forgot to write it here, but let me put this. Here I can have here getArgs. So I create a getArgs function where I will be handling all my arguments, and I will parse them, and then I will just return the value. And we can see how this is used, for example. So for example, I am working with PyTorch, then I create this in my own package. So my own model rather. So I have some model with utilities, and there I have this function getArgs, which is the one here above. And then what I do is, well, I will call the object, I'll call the function, and then reference it through this variable args. And in PyTorch, I will use it to define if I should use a GPU or not. Yeah? By getting if in the command line someone typed that I want to use GPU. So here we see at first glance, so it looks good. There is nothing to complain. You could even say, oh, but this is good practice because we are abstracting the logic. So we don't really need in our script all these huge arguments. We put it away into a util file, and we're just referring the function. The reasons why this is not nice are multiple. So first is, we are working with all these arguments, but yes, we made the code clean, but at the same time, we lost the sight of what it is. Second, we're passing the args object, so all over our code, and we don't really know what is happening. And as previously discussed with all the problems of you working with dictionaries, we cannot really make use of our IDE in order to check if something is wrong or not. And we have to check manually for each cases. So args is a dictionary. So if we want to see if GPU is available, we need to check if GPU is available, and if not, do some logic and so on. So it becomes cumbersome. What is the alternative? And what can we do instead? Well, the alternative is that we have a main.py file. So in the case of the Python example, I must clarify, it was in the train.py file. And I think they also use it in test.py, but it was in train.py. So here this happens when, for example, one is working on the command line and calling individual elements. So I will call Python train.py and do all this. The nicer thing will be that I declare a main file. What does that mean by that? Is that, so this is something that I can use both within my Jupyter notebook as just an additional cell, or I can use it as a py file. If it is working as a py file, Python will check it by looking at name. So, and if this is the case, then it will parse the arguments. And if not, it can work with values that we declare in the cell. This is the first advantage. The second advantage that we see here is that we can get the object and just pass specific properties from this object into the places that we need. And if you can see some thread in this discussion of antipatterns, you can see one important element. Always use variables and objects where you need them. Don't pass them unnecessarily. So if I need epochs, well, then I will pass here args.epochs where I need it, to iterate it, and not I will first pass the my dictionary and then do something inside the loop. And also the nice thing about this is that this way I can continue work with my code both in the Jupyter notebook as well as calling it from the command line. So I become more versatile by having a main.py file. And I would say from also cleanness of code, it makes sense to to distribute the logic and have an orchestrated file, main.py, where I will be calling to the necessary functions and so on. Here was something that we discussed with Alexei, and that so we saw in a previous class. So using, if I'm not mistaken, we work with so star args, but there is also KW args. What does that mean, and why is this not a good idea? Well, we can have a situation, for example, let's say that we have a class employee, but this applies also to basically any function, because any function can pass the keyword arguments or the arguments. And we can have a situation where we do not really know, we have so many variables that we're passing to our given function, or in this case, how we are instantiating the object. And we want to be clean, and we're also a bit lazy, so we will not type each of them in our constructor, in the init. But rather we'll say, we'll use this KWR to start, that it means that we're passing unlimited number of dictionaries. And this star initial data, it hints that it will be a unlimited list of properties. And then what we do is the following. We want to have some logic to catch that we're not passing things that we don't want. So we can have this, so this underscore means that this will be internally used, that this should not be used externally by a consumer of our object. So we'll say, okay, we have this class variable, internal class variable, with a list of the valid of the allowed attributes that we're passing here above. So we're saying, okay, so we iterate in our initial data, and for each element, we check if it's in the allowed attributes, and if it is, then we will set the attribute. This looks elegant because you say, oh, very nice. This way I can, I don't need to declare each property. I can also be, it looks clean, it looks very, very nice. So why not use it? Well, the first problem is that we need here to have some logic to detect all these different types. This is not nice. Second, what we have been discussing, explicit is better than implicit. Third, this can grow as much as we want. So if is a consumer of our code can pass anything that they want, it can have unintended consequences. And so we have this gives us this flexibility because later, if we have also another method in our class, we can also use it with these keywords. So we can start passing this object all over our code. And it can be comfortable, but it's not a good idea. Because explicit so is better than implicit. So in this case, what we do is we will declare specifically. We need name, surname, salary, address, phone, mail, and we will use the self. Yeah? But of course, this is not a clean-cut practice. And if you look at Stack Overflow, you will see a lot of debates. So summarize, what are the pros of using this approach of initializing through keyboard arcs and then setting attributes? Well, you're reducing code. Yeah? So less code duplication and so on. But what are the negative parts? Well, your code is less readable. You cannot really locate so what's going on. So this is a problem for IDEs. We can look into the signature of a function, of a method. And then we start writing a lot of code just to catch and to detect are we passing the right things. Yeah? So in the end, it might seem that it's more elegant, but it becomes a lot more code. And we can even see it here, obviously. So look at the amount of logic that is here with all these loops versus just having it direct explain. Okay, the files as intra-process communication. This is something I have used in the past, and I will explain my logic and why it's wrong. We can have a lot of, we can have scripts that are very long, and where we have intermediate steps. And in these intermediate steps, we are afraid that our machine will crash, that it will run out of memory or something like this. So we start saving the intermediate steps and then retrieving them back. So a very common example will be if we pickle our model. So nothing wrong with pickling models. It's actually very nice and comfortable. But in this example, so very classic sort of for a classification. We have our data in a data frame and we want to prepare it, train tests, etc. So we have fitted our model. And then we said, okay, we'll save it. We'll convert it into a pickle. So we declare the name and we dump it into a pickle. And later we said, okay, we have saved our file. So let's open the pickle to retrieve the our specific model. This can happen in the same file, or it can happen in another one that we're calling through importing. But the point remains. So here we're loading in the same iteration, it's not later, but we're in the same iteration, a save file. And the same thing can happen, for example, with in the case of pandas, where let's say that you have done some transformation on your data set and you store it, and later you read it again in order to train the model. So you might think, and I have done it in the past, and why did I do it in the past? Well, there were times where I would run out of memory. So I would say, instead of doing everything in one go, I do it in multiple phases. First, I do all my transformations, then I do all my training, and then finally I will do prediction and test it. The problem here is that this can have unintended consequences. For example, the case of pandas. When we're saving a file as a CSV in pandas, we will have problems with the format. So our integers will become doubles and so on, and these later can affect also, for example, on the integer length, it will be potentially chopped and so on. So just by saving it, we lost fidelity from our results to express it in some way. And not only that, but also this loading and unloading, it can lead to many bugs. So this will not detect it, but later we'll notice that there is some bug somewhere, and it's because we are loading and unloading data. So by storing it in our hard drive. There is nothing wrong with saving a model as a pickle. And in fact, if you want, for example, to do some kind of machine learning application, the most common way how to do it will be that you train it, you pickle the model, and later you create an application that will be having some API that will be querying over the pickle model. So, for example, the case where you have a very small server where you have your website, so you cannot, of course, train there. You train in your local server, just upload the train model as a pickle file. So this is a very nice practice, very, very popular, and it makes sense in that context. But in a context where we are so having intermediate steps, it's not a good idea to use the files as a way to exchange objects. In this case, pickling and unpickling our model. The best practice is we have to work directly in memory with the results. You might say, oh, but if I run out of memory, if it doesn't fit and so on, well, here we have to look into alternatives, how we can do it. But nevertheless, this does not really justify that we'll use files as a way to communicate across our code. So yeah, the 18th one, we have just 2 more, and then we can approach our exciting test. So I hope you're all excited about it. Make a function that operates on a list. And this is also very debated. I was looking at it and a lot of people argue about that. So what does that mean by that? So this is very common in machine learning in that, so imagine the situation where you are training with your, so you're training your model and you are working, you have to iterate through it because you have some epochs, or for example, you want to use multiple models, so you have to use each model each time, or maybe you have multiple data sets, so in the end you have to iterate through something. So what you could do is just say, okay, I declare my function. In this case, I am passing, so the signature will be with epochs, which is is an integer, and then I will use this to iterate. So for each epoch, I will do something. In this case, I will just try to compute so the loss. It looks good. You will find it everywhere. Probably you're doing it. However, this is not ideal. Why is that? Well, because especially if we're working with parallelization, and this is something that I don't think that we'll have time today, but definitely tomorrow we'll cover how to do our code parallel. If we are having the list iterating through the function, we'll not be able to make use of this. So what can we do instead? So the obvious thing is that we will, instead of using a function to iterate inside, we will iterate outside of the function. So you can see that we are calling again our for loop, but here what we're doing is for each iteration we're calling the function train instead of vice versa. In the previous case, for each in the function train we handle all the logic. And our reason why we would not like to do this is what we have been discussing above. In general, passing full lists or dictionaries or any type of data collection into a method, into function, is not exactly very clean. Just it makes much more sense to just pass exactly the element that we want. Very common when we are so doing exploration and working and so on. And so for machine learning class homeworks, it's a classic that we see a lot of dead code, a lot of comments that are never called. So what does that mean by that? And this is obvious that we still keep doing it. We're exploring and we tried very different things and we keep commenting in them, commenting in out. So for example, in this case, in the end, we just want X and Y and our test size and seed, but we have multiple test sizes and seed because maybe some work, another one didn't work so well, etc. So we keep it out of comfort. But then we submit our code to a colleague, to our so TA in the machine learning class, and then we have to see this, that it looks very ugly, and it obfuscates the code because we have additional lines that are not necessary. And here the obvious reason is just remove it. Yeah? So we should just keep, once we are sure that our code is more or less ready, we just remove all these lines, and the only thing that should be commented should be actual comments on the code and not some potential variables that you use and work, etc. So very easy, and still we do it all the time. Non-idiomatic partners, the last one, but also very important, and I have here an example because in pandas I see it a lot, but it also applies to Python and so on. Although Python is an object-oriented language, there are many libraries, for example, NumPy or Pandas, or in general libraries in the Python data stack that are much more faster, efficient, and cleaner to work with if we use their idioms that are of a functional type. And what does that exactly mean? Let's look into an example. Yeah? So with Pandas. And I have seen that many times that this happens. So let's imagine that we have a file that we have to, basically a data frame that has 2 columns, daytime and a column for energy. So we just convert the time to a date, etc. So it's perfectly fine. So, and let's imagine that we want to calculate the third column with some logic, that it will be the cost per kilowatt. If this cost is static, well, the very basic thing is we will just multiply the column by this constant and create a new one. But what happens if we have some logic behind? So if there is some tariff for the evening, another one for the day, another one for the night. For example, we want in this case this, that we see that we have varying values depending on the time of the day. So we start by defining a function where, given the time of the day, we'll have some kind of logic. So if it's in the morning, it will be so 12. If it's across the day, it will be 20, and if it's at night, it will be 28. And we also want to do it professionally, so we'll raise an exception in case that, or in this case an error, we raise an error in case that it's not an actual hour, and we'll put invalid hour. So, and at the end, we'll multiply it. So it looks very clean, and we want to use it in pandas. We have worked with a list, we have worked with dictionaries. So the first idea that will come to someone working with pandas at the beginning, who is familiar with Python, is, okay, pandas is rows, and this is basically elements. So why not I go through each row and I do this? I check the first row, I will check what's the time, I will check what is the energy kilowatts, and I will multiply it based on my logic. It makes perfectly sense, and it's object-oriented, and it works. So this will look like this. We can see here, we have our data frame. We here get the number of rows in data frame, and then we will iterate it by range. And here what we do is we need to get the exact row. So we will use iLog to get the row in question, and to get back, and then here energy kilowatt, we'll get the column in question. So here is for energy used, and here for hour. Basically same logic. We pass these two to our function here above, and then at the end, we'll just append all elements into a list, and we know that list can be converted into panda series, so we can just do this. And then we call our function here. So it makes sense. You might say, nothing wrong here. And so why not use this? Well, the problem with this is that it is very, very slow. So it will take us, for this very small example, 3.1 seconds. Imagine that we have a large data set. It will not be possible to compute it in some cases. And what is worse is that this is not even necessary, because there are much more elegant and efficient ways how to do it in pandas. And one of these is just using apply. Apply is a method in pandas that lets you apply a function, for example, a lambda, to all rows and all columns in the data frame. So how does it look? Well, here, what we have is basically, we want to create a new column in pandas that we call send. We have our data frame, and in data frame we call apply. And here we have the logic with lambda that I was mentioning before. This is an annoyance function where it will receive as a parameter row, and in the logic, it will call the apply tariff function based on these values here. And we're telling axis, so to tell it that this should be applied across basically all rows, and then we'll call it. And here it took only 0.272 seconds. So it is obviously faster, and not only that, but it looks much more cleaner and much more idiomatic. So in this example, we saw that just in a very simple case, we work with something that is much more elegant, and it's also much more faster. And this applies not only to pandas, but basically everything in the data stack of Python. So always look for what are idiomatic ways to do things, not only because they do look elegant, but also because often the authors of the libraries have made sure that the idiomatic ways are more performant than the non-idiomatic ways. So we have come to the end of our theory part. Now is 2.7. Let me just see here quickly the comments, if there is something that I should look into. Okay, I see that Ivan did an amazing job in answering to everyone. So this brings us to the second part. So that we were discussing that so far we have not really been hands-on. And we need to, in order to become better software engineers, we have to apply what we have learned. And for this, we have come up with a nice task. So what will it be? And this will be the quiz for today. Let me move this. And I will push it now to our repository. But the idea is the following. In our seminar repository, you will find a Jupyter notebook. This Jupyter notebook has a very basic but very common way how a data scientist will work with a problem. The idea here is that you will be scraping some data from some couple of websites. You will do a little bit of manipulation to this scraped data. Then you will prepare this for a classifier, and you will train your classifier and show the results and some plots. So far, so good. And how you will proceed? Well, we will apply basically all that we have learned so far. So you have to fork the repository in GitHub, so meaning you will create a new repository for yourself. You will clone this repository into your local account, and you will create a new folder so we don't get lost with the logic. And in your folder, what you will do is that you will seek to convert this Jupyter notebook that it works, it does its task, but you will see that it's not that nice, into an actual script that can be shown to someone, and that is much more Pythonic. This script should be able to be run in the terminal. So that means that we should be able to pass some parameters. You can choose which parameters to pass. Here is up to your imagination what makes sense or not. You must use idiomatic Python and basically apply what you have learned last time with the patterns class, now with the Antipatterns class, and then decide where you want to use functions, classes, objects, more functional programming, and so on. Also, there might be situations where things are too variables, so you can abstract it, and you would like to separate the logic from the configuration and so on. So the objective here is that you do better code. You do not need to work on improving the results. You will see that actually the classifier gets very poor job. So the prediction is very, very lousy. But that doesn't matter, because here what we're working on is not on getting the best possible result, but rather getting the best possible code that fulfills the objectives of software engineering, which are maintainability, reusability, correctness, testability, reliability, portability, and adaptability. So once you have looked into what can be read, removed, and so on, and you will basically save this. Things to note is that you can use any tool that you want to work on it. Let's say Vim or PyCharm, or just work with the Jupyter notebook and then convert it into a Py file. It's up to you. In the end, what we want is a .py file. And also another thing that is comfortable is that all these libraries are standard libraries. So we're not using here anything exotic. All this is included in the Anaconda distribution, so you should be able to work from the beginning. And that means it's also kind of important to collab in case you want to work with it. So once you have done this, you will save the Py file in the folder with your name, and you create a bash file. So we're learning about bash files early on. So in order to call our Python script, and where you will also put the parameters for the bash file, for the Python script, I mean. Once you have finished this, you will commit all this to your fork with a nice comment, and you will do a pull request on Git. And basically, you will have 90 minutes for this task. So now is so 2:11. So by 3:30, 3:40 basically, we will finish all our quiz, and we will look into the timestamp. So you will have completed this quiz if the timestamp is within the 90 minutes. You also need to, I will now also activate it in Canvas, you need to put the hash of the commit as part of the quiz. So it's a formality that you submit it on time. In the quiz, explain how to do it, so don't worry for this. And now we'll not have time today, because basically this is will be out of time after that, but likely tomorrow we'll cover some solutions, because it's important that we see how do we discuss code and so on. Software engineering is also a lot about communication. So we'll pick some solutions and we'll discuss it in the class. I'll discuss how can be done better. So now let me just push here into our master. So I'm pushing it. Yes. So let's see here. So not this one here, not in myself, but let's go to in our Audace group that you should have. We'll go here to seminars. We have here week 2, day 2. And we see here already the instructions and everything. Yeah? And we open to see that everything works. And we see what we are supposed to do here. This is basically the code itself. So far so clear. Let me see here. There are some questions in the chat that I have to answer before we can start. So can this lecture file be published? Yes, it will be published once we finish. We start in 5 minutes. 19 minutes, maybe you can pass. No, well, no. So this, I mean, we'll not start exactly now. We will start. I will put that we start at 2:20, so 7 minutes from now. So that way you can, or let's do we'll do 2:30. 2:30 we start, so you have time to go for a glass of water, have a bathroom rest, and so on. 2:30 we'll set, and you have time until basically. Well, what if I don't have right now time? I have a seminar with my lab starting at 3 p.m. Well, actually, the class here ends at 3:30, so in theory, you should be able to still work with it. And honestly, this is rather simple. So I think that 90 minutes is more than generous. But okay, let's do the following. You will have time until this. So we start at 2:30, yes. But so we can do that. You have until 5 p.m. So that way you have enough time for classes and whatnot. So you have until 5 p.m. It is today 5 p.m. So to work on this, you will submit it by a pull request, and you will also do the. You will also in Canvas you will submit your results. You might say, why until 5 p.m.? Well, for a very simple reason. I see that now we have 22 participants. This is a little bit less than our class. And of course, if we have give time until tomorrow or so, well, anyone who was not in the class can very easily just work on it without participating. And this is not the meaning of the class, but rather that you pay attention and that you were here present. So it's also a way to control participation. Therefore, we will start now. All the code is available in our, yes?
Could you return back to the 15 anti-pattern, because I had a question about it.
Okay, let's first cover this before we get started. So let's go to the 15 anti-pattern. No problem. No problem.
I was confused that we had stop, sorry,
yes.
16.
Okay, 16, yes.
I'm confused that here we have initial data, a tuple of dictionary. Is it right?
So the question is, so we have here a
so
tuple.
Initial data is a tuple of dictionaries, right?
So here the initial data, it will be, so initial data is just initial data is just a list. The star, 1 star means list, 2 stars means dictionary.
I mean that we iterate through the initial data, and here we see from the code that we expect it to be dictionary, each element of initial data.
In the dictionary here, this one here, it actually comes from key WRs. So this is also this is what I meant in that key WRs can contain anything. It's like a bag, and I do not see it, but actually in key WRs I'm passing this dictionary. Sorry, no. The dictionary is the element from initial data. Yes.
Yeah. Yes.
And these allow attributes come from here, and initial data, yes, it can be basically a list of dictionaries. That's true. Yes, excellent. So
because I'm confused of that pattern that we put the list of dictionaries instead of the only one dictionary as usually we use as keywords.
Well, this could be because, for example, it could be that initial data has not only this dictionary, but could have other things and so on. So this is exactly what I was mentioning, that it can make things practical, but it can result into confusion and so on. So here, that's why it's very important that we are very explicit in how we initialize our object and only declare the properties that will be used in the object. Okay?
Mm-hmm.
All right. Well, then basically we have now our quiz. You can see I am pasting here the URL in the chat. But it's basically in our Adase group, so GitHub repository. And here are also the instructions with everything that needs to be done. Here I wrote the 90 minutes, but given these changes that happen and so, yes, one can start whenever we want until 5 p.m. Yeah, so I will update now this file so it's not confusing. I will also, what matters is two things. One, I will open the quiz in Canvas, and there the submission consists on the commit hash that you get from GitHub. Commit hash is basically this here. So you will paste, I mean, this is mine, you will get a different one when you commit, but you will paste this into the Canvas quiz, and this will basically certify that you did it on time. So you can have now a break and start a bit later. For me, this is definitely more than generous 90 minutes. I think it's even faster because it's relatively simple, but I think a lot of this can be done creatively. So have a break, and you have basically until 5 p.m. to submit it. And tomorrow we will go through some of the solutions, as well as introduce parallelism. So if there is no further questions, let me know. I will be available also on the chat of our Telegram group in case that something is not clear or you might need some clarification. But basically, we have now our quiz. Go take a break and start working on it, but please submit it before 5 p.m. All right? So
yes, I asked a question about one of the patterns where you had this do this. If you have a function, it should only process one element, right?
Correct, yes.
My question is, in NumPy, MATLAB, PyTorch, there is this thing which is, well, basically you always need to strive for vectorized operations. You can't really have your data as a list of, for example, tiny arrays size of 3. No, you usually have a table that is like 10,000 by 3, right? So you cannot really apply element-wise function. You need to write a function that is aware of how your objects are stacked in a single PyTorch array.
That is correct. That's correct. And this is the case that some libraries they work much better like that, and especially so with scikit-learn and machine learning libraries that happens. I will say here, and again, so antipatterns and patterns, this is not so the Bible in that if you don't follow it, then so it will be terrible. And also it's open to opinions. And in this case, given that so many machine learning and data science and numerical libraries are made to work as a function with a functional approach, then working so with elements from an iteration is suboptimal. Here, I will say that this specific pattern applies to, for example, configuration or things that are not really necessary. For example, here I will pass the whole data frame. And so I will pass my X train, and then as a full object, I will not do for each row in the train file, do this training. No. However, there is a good reason that it makes sense to work with just with individual, so to iterate on elements and not have functions that iterate inside. We'll see tomorrow when we discuss parallelism, for example, one case, but indeed, one has to check what's the best practice for the library that the person is using and apply it accordingly. And definitely that's the case for scikit-learn and PyTorch and so on, that you cannot pass like batches as an iteration or something. You have to pass the full data set, the full array or matrix. That's true. Okay, so that's basically for the theoretical part. And as I said, I will be available in the chat. You have the GitHub repository with the task and instructions. And I will update it now to reflect that we have until 5 p.m. to submit it. And I will also release the quiz so you can submit the hash for the submission. All right, well, great that we have this very active conversation, over 70 comments on the chat window. So it was very heated. And let's do this. And otherwise, we'll be meeting tomorrow to go through some solutions as well as discuss parallelism. Have a nice day and all the best success with our nice in-class quiz. Have a nice day.